Okay, so for number 9, it says a uniform plank is 6 meters long and it weighs 80 newtons. It's balanced on a sawhorse at its center. So let's make a quick drawing of this. So here's the plank. It's 6 meters long. It's balanced on a sawhorse at the center. An additional 160 newton weight is now placed on the left end of the plank. So we're going to put 160 newtons over here at the left end of the plank. And the question is, to keep the plank balanced, where do you have to put the sawhorse to keep it balanced? Okay? So, I don't even know why I drew it like this. So, the fact that the plank is uniform is important. Why is that important, you guys? Good. It means that your center of mass is located right at the center, right? So, there we go. Let's move that out of our way. All right, so our center of mass is right at the center. So here's our force of gravity. The problem tells you that it's an 80 Newton board. Everybody good up to there?
I think I just read I was like confused on the wording of the problem.
I thought
it must be with what distance to the right. And so I didn't know what it was.
Oh.
Then I was confused on like why would we go to the right.
That is worded horribly.
I kept thinking it was like wasting some meters like on this.
Yeah, I totally see why you were confused on that. Okay. Do you guys want me to run through it real fast? Yeah. Okay, so I'm sorry, you're right. It's worded horribly. I'll fix that. So the question is, where does the sawhorse have to go to get it to balance? So the idea is it's got to go somewhere between these two forces, right? And we just got to figure out where. All right? So there are a couple ways you can do this. Thoughts about where to get started, Teddy?
Could you do, or like set it equals, so the distance between the pivot point, or like FD equals FD?
Yes. So when you say FD equals FD, what are you choosing as your pivot point?
Let's see, find, how do I put this? Just like find like somewhere you can plug in where 160 newtons times the distance will equal 80 newtons times the distance.
Okay. Yeah. So I think what you're saying, and this is what people usually tend to do, is people usually think, all right, well, I'm trying to figure out where the sawhorse goes, right? And if it tips, it's going to tip on that point. So what people usually do is they pick this as the pivot point, and then they call this distance, I don't know, let's call that distance x. Oh, well, I guess better yet, let's call this distance x. I wish that hadn't happened. Let's call this distance x. And if that's x, then what would this distance be, you guys? 3 minus x, right? Follow? Okay, so this totally works. I'm a little bit uneasy with it, though, because if this problem had any more forces on it, this would start to get really ugly really quickly, right? Do you know what I mean? Because what we've done is we've chosen our pivot point to be at an unknown location, right? Which means that we literally don't know any of our distances, all right? So this will work. Give me 2 seconds, Cam. This will work, but you just got to be careful. And so to Teddy's point, so we're going to get, well, the torque from this thing is going to be 160 times 3 minus x, right? And that's got to equal the torque from the other thing, which is 80 times x, and then solve that, and it gives you the answer. And that totally works, okay? After I get Cam's question, I want to show you guys another way of thinking about the same problem that probably isn't any easier, but if the problem was more complicated, it would definitely be easier. Yeah, Cam.
Well, there's another way to do it. Could you just have the force from the fulcrum or whatever it is just equal, since the net force has to equal 0, compared to P
Yes, and I like that solution better. And that was exactly the other method I was going to show you guys. So before I do that, does anybody have any questions on what I did here in red? Okay, so I agree with Cam. Suppose we had another kid sitting at the other end, right? Then we'd have another, the distance to the kid would then be x plus 3, right? So you'd have, the more forces you have there, the more times you're going to have to worry about that unknown distance. So I agree with Cam. I think what I would do is I would call this the pivot point, and I would say, all right, well, if this is my pivot point, there are two forces. There's the gravity from the board and the force from the fulcrum, right? You guys see that? What does the force of the fulcrum have to be, you guys? It's got to be enough to cancel both of the downward forces, right? Our net force has to be 0. So this has to be 240, right? Does that make sense? So now I can write a net torque equation here where I'm going to go, all right, well, the net torque around my pivot point is the torque from the fulcrum plus the torque from gravity, which is 240 times x plus 80 times 3, right? And what does the net torque have to be, guys? 0. And then, let's see, check your signs. And yeah, I think that this should be negative because it's going to produce a clockwise torque, right? Cool. So 2 seconds, Adam. So Sambo, you said wouldn't it be negative 80? It's not negative because the force is negative. It's negative because the torque is negative. Do you understand that distinction?
No.
So,
What do you mean the force? The force is going down on one
right.
up on the
But so remember, one of the things I was trying to get across to you guys last week, I guess it was probably Wednesday or Thursday. It wasn't Wednesday. It must have been Thursday. Is that when you calculate torque using this equation, all this does is it gives you the magnitude of the torque. Okay? So just because your force is negative does not necessarily mean that your torque is negative.
Right, because the distance can also be negative.
Yeah, but my strong encouragement, is that the right word? Was for you to, instead of thinking of the signs on your force and the sign on your distance, to just ask yourself, what direction torque will this produce?
Okay.
And so the idea is, this force is downward, so with this pivot point, that's going to produce clockwise torque, which is negative.
Okay.
So that's what this negative is.
Then at the same thing, isn't that force that we're trying to make that is 240 making it rotate the same direction?
This? No, my pivot point is here. So, all right, so let's do this. So if I solve this, you get 240x equals, unfortunately, this also turns out to be 240, right? Good. So this is saying that the torque from the fulcrum is positive 240. So that's telling me that the fulcrum has to produce positive torque. So if this is my pivot point, then that would make sense, right? Pushing up would be
Oh yeah.
counterclockwise, which is positive, right? Follow?
Yep.
Everybody good? Adam, you had a question 7 hours ago, and
I was just confused because I thought we were supposed to cancel out the 168 because that's what we made out of the point. It's okay.
say that again. I did cancel out the 160. That's why I didn't include it over here.
No, but like when we were talking about what the force of the fulcrum has to be,
Oh, I see.
we were accounting for the 160.
So, I gotcha. So you got to be careful. When you choose your pivot point, that affects your net torque equation, but not your net force equation.
Gotcha.
Does that make sense?
Yeah.
I'm glad you brought that up. That's a thing that I've seen other people get tangled up on. Did everybody follow that little conversation I just had with Adam?
Yeah.
Choosing your pivot point only changes your net torque equation, not your net force equation. Good?
Yes.
Cool. AJ, remind me to send an email at the end of class.
Oh yeah.
All right, everybody good with 9? All right. Anything else on that first page that you guys want to go over?
Yeah.
Yeah, then 4. Number 4? Did you get 3?
Yes.
Huh.
Same thing.
It's almost the exact same thing, yeah.
Why is it F2 minus
Let's run through it though. I think there's value in running through it.
Yeah.